Today we will study LC oscillations. We have been discussing that we are getting signals in the form of variable voltages. In a wire, if I measure the voltage here, this voltage is positive 0, negative 0, positive 0, negative 0. Voltage is same thing as electric field. Electric field is a differentiation of voltage. So, that means we are getting a variable voltage or we are getting a variable electric field, and this variation is known as oscillation. How do we get oscillation? This oscillation we are getting with help of a circuit that is known as LC oscillation circuit. In this we are using mainly two components which are responsible for oscillation, that is one inductor and one capacitor. Resistance of course is everywhere. We cannot make it zero. So even if I say or I don't say, resistance is always there. But since that resistance is not taking participation in this, we are only discussing inductor and capacitor and what action takes place between them, so that we get variable electric fields and magnetic fields. Now this circuit will help us in three things. Number one, when we are sending signal with help of cables, like you get the signal through a cable for your TV and for internet. What do we get in that? Oscillating voltage. Use this circuit. Number two, we are getting electromagnetic field, and electromagnetic field is again oscillating electric fields and oscillating magnetic fields. Who creates them? This circuit. Through LC oscillations, the charge is oscillating and we get electric field and magnetic field. These are the oscillating fields, and with that our mobile work or any wireless device, whether it is working through Wi-Fi, Bluetooth or any other wireless medium, that is by this circuit. Third thing, sometimes we are converting direct current through battery to our household supply, which is AC. So whenever we need to convert DC to AC, DC is a direct supply of energy, AC is a oscillating voltage. So for oscillation again we need this, and this technology we are using in our inverters. So inverter is creating DC to AC, both are energy form. So that's why this is very important circuit. Now this is creating electromagnetic waves which we use a lot, and I told you oscillating voltage signals. Oscillating EM, and this makes waves, that is electromagnetic waves which we use in mobiles, and oscillating voltage that is required for inverters. So this oscillations, how do they take place, that we will study here. So first, the circuit diagram is a very simple one. There is one capacitor and one inductor which are connected in parallel. At any given time there is energy with the capacitor because it has been charged. How we did this? The first step, we say that here we have fitted one battery which has got energy and we switch it on. We switch it on. When we connect it, switch it on, then the positive charges enter here, negative charges here. When these positive charges wants to go to the negative charges through this, then because it is a DC, here these are blocked. But you see the nature here, a very important thing. Initially here the current was 0. Suddenly when we switch it on, the current increase from 0 to maximum value, I naught. 0 to maximum. This is a variation of current. The moment current jumps, there is a variation of I, there is a variation of current in this circuit, and what is the nature of inductor? It opposes any increase or decrease in the circuit. So it opposes it. So changing current, it will not allow to pass. So it does not allow to pass. If this does not allow to pass, then all the current goes there and this will also not allow to pass. So what will happen? All the charges going here get deposited at this point. So all this plate become positive and this plate become negative. After that we switch it off, and when the capacitor is charged we switch it off, and we will study it now with respect to the energy which has been given in this electric field. You know the energy in the electric field is half EC square. It has a energy, it has a electric field. This is our situation number 1 we are going to study. Now what happens after that? See, here what is this situation? The situation is, here is electric field and here is no magnetic field. These positive charges are connected with a wire through an inductor to this negative plate. If it is like this, then all the positive charges would like to move to negative charges and they adopt this path. If they adopt this path, then a current builds up. When this current builds up, the current increase. In which direction? Clockwise. I write it here. The current is increasing clockwise from this to this. When the current is increasing clockwise, a magnetic field is developed in this, because you know whenever there is a current flowing in a solenoid or in an inductor, a magnetic field is built up in that, mu naught and I. So this is built up there. When it is built up there, energy is also built up in this, and this energy is half L.I. square. Okay. When this was here, again come back to this. When it was here, there was an electric field in this direction. Let us call it plus E naught, maximum electric field. How much was magnetic field here? 0. So plus E naught, this was 0. The current was 0, and from this to this current goes on increasing. From 0, it was 0, then it starts increasing by this charge. Current. Now in this what happens? Here we study E is equal to E naught. The energy is full form in electrical form. Energy is fully there in electrical form. Magnetic energy is minimum. This. Now when the charges are going here, current develops in it, and this current I write minus I because it is clockwise. When this current flows, grows, increasing clockwise, because all these charges want to go to rush up to negative charges, the current from 0 increase to I value. When the current increases, then there is a magnetic field developing in this. But due to its nature, it opposes the increase in the current and there is a magnetic field. Now because of this magnetic field, there is magnetic energy. Energy magnetic. This becomes maximum in it. Now all these charges, initially they push very hard because they are very large in number. Slowly when they are consumed, when they are in the passage, this strength or the voltage falls down. Ultimately, all the charges have gone and the electric field has become 0. All the charges in the form of current goes in this wire. When the current flows, it makes an opposite magnetic field and this magnetic field become maximum. Electric field has become 0 and due to this current, magnetic field has become maximum. The current is flowing. But when all the charges are consumed, then no more possibility of the current. So current starts falling down. When full charges are there, the current increase. But when the pile of the charges decrease, current starts decreasing, because if there are no charges, there will be no current. So this finally stock finishes. Now when this stock going to finish, the current decrease. What is the nature of the inductor? When the current is decreasing, that is this stage. Now we have come to this stage. This clockwise current increasing. Why? All the charges were going. Increasing current. The charges are vacated. No charge here. So what will happen to current? Current is decreasing. For increasing current, what is behavior of the inductor? It opposes it and all the current energy is absorbed in it. Right? Now, the current, when charges are finished, current is decreasing. It remains clockwise, but it is decreasing. When it decreases, then it changes its behavior. What is its behavior? For decrease of current, it will support the current. If the current comes from here, it blocks it. Okay, now the current which has grown to the maximum start falling down. When the current falls down, then what does it do? It does not want that change and it supports the current. When it supports the current, all its energy it uses to push the current to this direction. Push the current here. When it pushes the current here, its energy is gone. Its energy is gone and magnetic field has become 0. What happens to energy? It has pushed all the charges here. The charges come here, get filled up on this plate. It has used all its energy. The charges have come to this plate. Now, positive are here, which started from here. They come to the opposite side and here we get an electric field in opposite direction. Now, this electric field is in opposite direction here. There is no magnetic field, 0. Okay, the current was decreasing. And when it push it all, then what happens? It has no more energy to push the charges and the current becomes 0. Now, when the current becomes 0, what happens? All these positive charges, they wish to go to negative end and here is a path available. This copper wire. So, start current this way. Now they start current this way. So current increase anti-clockwise. All these charges again start traveling this way and they form electric current. They form electric current. When they form electric current this way, then initially when they have full charges, the current increase clockwise. And when the current goes in this direction, what is the nature of the inductor? It will oppose the increasing current. So it makes a magnetic field here. And here we get a magnetic field which is B0. Okay. So again, which was minus B0 here, here we get a plus B0 magnetic field. Okay. This magnetic field opposes the increase of current in this direction. But when all the charges are consumed, what happens to the current? The current start decreasing because all the charges have been consumed. Now, if the current is decreasing, what this storage of energy will do? Answer, this will support the current so that this increase of current should not decrease. So, it gives its energy. It gives its energy and this support the current. What is happening? The current which is anti-clockwise is decreasing. Current decrease anti-clockwise. If current decrease anti-clockwise, what will happen? It will give its energy and make the current flow. Keep the current flow, so that current means what? Motion of positive charges. So all the positive charges flow and reach this point. And this plate is getting positive charge, this plate is getting negative charge, this is vacated, no magnetic field, and here we get a situation which is situation number 1. See this. So 1, 2, 3, 4 and again back to 1. So these are the 4 stages. Again they come here. This is the current decreases, so anti-clockwise, and what is happening? It gives its energy and send all the charges back to this plate. Now when it come here, the current become 0. From this 0 current, again these positive charges go here and this cycle start. So what we find? The different parameters. See, electric field was positive, 0, negative, 0. Again positive, 0, negative, 0. What is the magnetic field? 0, negative, 0, positive, 0, negative, 0, positive. See, magnetic field. If I make a graph of magnetic field, 0, 0. At this time, this full 4 steps makes one time cycle. So this is T by 4, this is T by 2, this is 3 upon 4T, and this is after 1 full T back. Okay, so at 0, then at T by 4, B is minus B, again it is 0 and then again it is plus B and finally it is again 0. Electric field maximum 0, here again it is minus and again it is 0 and again it is plus. Electric field, this plus, which is again position number 1. It starts again, it starts from here, the second cycle. So what is happening to electric current? Electric current here, clockwise from here to here, clockwise maximum, clockwise decrease, become 0, anti-clockwise increase, become maximum, decrease, and after decrease become 0. Again clockwise increase, maximum, decrease, 0, anti-clockwise increase, become maximum, decrease, become 0. So there is a oscillation of current. So this oscillation of current also, if we want, we can draw out here, and here it will be oscillations. Again we can always make it current 0 to here we can say this current is increasing 0 to clockwise at this 0 to clockwise. This is current. Okay, then it becomes 0 and again like this, and here it is like this. This is I. So in this way, whether it is electric field, whether it is magnetic field, whether it is electric current, or whether it is potential across capacitor. You see, this is plus V, 0, minus V, 0, plus V, 0, minus V, 0. It keeps on oscillating. So here is V. So this is I graph, I, this is V graph, this is E graph, this is B graph. So in this way we get the oscillations. Every quantity, whether it is electric field, magnetic field or energies are also oscillating. Here electrical energy, this is 0. Here it is magnetic energy full, this is 0. Here it is full, it is 0, and here again electrical is 0, magnetic is full. So electric field is oscillating, magnetic field is oscillating, electric current is oscillating, voltage is oscillating, and energy is oscillating. All the quantities are oscillating in this time period. That is why this is known as oscillation. So what is the time period or frequency of oscillations? The answer, omega, angular frequency, is 1 upon root L.C. With this, if we write omega is equal to 2 pi upon t, then what is t equal to? So 2 pi upon t is equal to 1 upon root L.C. So t is equal to 2 pi root L.C. time period. What is its frequency? What is its frequency? Frequency nu, that is equal to 1 upon t, that is 1 upon 2 pi root L.C. This is frequency, this is angular frequency. This is time period of one oscillation, and you will see here, if the value of induction is large, if capacitance is large, then time period is large, and it is very well understood. Larger is the induction, more time it will take to absorb the energy, then only it will start releasing the energy. Larger is the capacitance, more time it will take to get charged, and after that it will start the next cycle. So the time is directly proportionate to inductance and capacitance, and frequency 1 upon root L.C. Now C and L, these values are decided by us, we are fitting these. So whenever we change the value, we can change the frequency of this oscillation. Now these oscillations are giving us all these four things. If we fit an antenna anywhere, let me fit an antenna like this. If this is an antenna, then here we get the electromagnetic waves, this propagating electromagnetic waves. This is the tower which gives signal for our mobile, and there is this circuit. This is the cable from this place, or from this to, or from this to, we get a cable. That is what we call cable, coming from that TV supplier who is supplying the cable here, right? So either we get oscillating voltage or we get electromagnetic wave, and the same voltage we can use in our inverters, but there are so many circuits we have to use. So this is L.C. oscillations. Now these oscillations, will it go forever without energy supply? We have understood how the oscillation takes place. Is there any loss of energy? Answer is yes. If we draw a graph of amplitude of the oscillation, how large is the electric field, then what do we get? We get a graph, and that graph will be, I will make it here, but it will be little small. This is electric field or magnetic field. So we get a graph like this, but second time it is like this, third time it is like this, fourth time it is like this, fifth time it is like this. So you see this phenomena of losing energy with every oscillation is known as damping. and these oscillations are known as damped oscillation. All these oscillations are damped oscillation because after certain time their amplitude decreases and it goes on decreasing. Whenever you make this diagram, please remember, make this guideline as a parabola and then fill it like this. So this you have studied in the chapter waves of the class 11th. What we want that whenever there is oscillation, this should be this way. What is this? Undamped oscillations. So this is damped oscillation, undamped oscillation. We are not giving energy to it. We have given energy once, allowed it to oscillate this way, this way, this way. So first time electric field will be 10, second time it will be 8, third time it will be 6, 4, 2, finished. So if we want to continue this like this, so we have to give it energy, and that energy we give with help of a transistor, so that there are certain parameters. The energy is given only when it is in the same direction. That is very much synchronization is required. So for that we need a special circuit, and we will study that circuit as a transistor to be used as oscillator. In that we fit the same two things with a transistor. Transistor regulates their timing, give their energy to the full values. Transistor not regulate timing. Timings are regulated by them this way, but transistor regulate their voltage. It does not allow them to fall down. Through the battery it is giving them energy. In this direction, it gives them energy so that it becomes like this. So this is all about oscillations and oscillation circuit. This is also known as tank circuit. Why tank circuit? Answer is, whenever we want to send an electromagnetic wave, we need to send it for my mobile, for your mobile, for every TV station we have to send. So we want different frequencies. How do we get the frequencies? From where do we get? So the answer is, we make a large tank. Like analogy is, it is a large tank of water. Whenever you need water, just put your mug through it, get it, put your mug through it, get it. So that tank gives you the different frequencies. This is our tank circuit, and from here we take that frequencies. So this is time binding circuits. So in next chapter we will study another AC circuit. So far you have seen tuning circuit and LC oscillation circuit. What is the relation between them? Where do we fit this LC oscillation? When we have to send the signal with a particular frequency, transmit the signal. So this is fitted in transmitter section. So this is sending the wave, L.C.R. series circuit is receiving the wave. This is how our mobile is working. This is how all wireless devices are working. Thank you.